Don't forget to subscribe and ring that bell.
Hey, welcome. I am Visca the teacher. It has been a while since I posted anything online, but I'm back and we are going to begin to cover the Algebra 2 Regents high school examination, the one that was just taken this past June of 2023. This is the first video, and I will cover multiple choice problems number 1 through 8. And unlike the AP Calculus videos I make for those exams, we always get to use a calculator on this exam, which is nice for us. Let's begin. Just a quick note, part 1, which is the multiple choice, has 24 questions. Each correct answer will receive 2 credits, and no partial credit will ever be allowed on multiple choice. It's either right or it's wrong. Use information provided for each question to determine your answer. Note that diagrams are not necessarily drawn to scale, and for each statement or question, choose the word or expression that, of those given, best completes the statement or answers the question. Record your answers on a separate answer sheet. Of course, you're given a bubble sheet. We're just going over the problems today. Problem 1, the population of Austin, Texas. Oh, I'm a Dallas Cowboys fan, so anything Texas I love, but I'm from upstate New York. From 1850 to 2010, we have a table that has the population of Austin, Texas, and it's summarized in this table below. They give us the year and the population, and they ask us over which period of time was the average rate of change in population the greatest. Now, I love this type of easy question, but I hate this type of easy question. How come? First of all, the easy part, average rate of change. If you don't know that rate of change really just means slope, and I still say that in my calculus class today, that means I'm going to use y2 minus y1 over x2 minus x1. All right? That's the easy part. But why do I not like this problem? They give us 4 intervals of years, meaning they say from 1850 to 1910, 1850 to 1910. I'm going to have to find the average slope for that. Then they give us from 1990 to 2010. So I'm going to have to go from 1990 to 2010. I think you see what I'm about to say. I've got to find the average slope there. Then I got to go from 1950 to 1970. From here to here, I got to find the average slope. And last but not least, then I've got to go from 1890, it's right here, to 1970, which is right here. Okay, and I've got to find the average slope 4 times. Now, I have done this for you, okay? I know what the answer is. My answer should be choice 2, all right? Now, I'm going to show you how to do this right now, okay? My x's are the year, and my population, that's my y's. In case you didn't know, when we ever have a table, x's are always listed on top, and y's are always listed on the bottom. So if I'm going to go from 1990 to 2010, let's say this is my x1, this has to be my y1, which means this would be my x2, and this would be my y2. Okay, I'm literally just going to plug them into this formula right here. So we have y2, which is 790,390, minus y1, which is 494,290, all over x2, which is 2010, minus x1, which is 1990. Now, you won't be able to do this in your head, but we got this calculator that we love so much, and we're going to use it. I'm going to hit alpha. Ooh, that was strange. Alpha y equals enter. And I'm going to create this fraction. And I'm going to type it in just like I have it. 790, 390 minus 494, 290 over 2010 minus 1990. If I do that right, my average rate of change is 14,805. All right? Now, if I did the rest of these in the same manner, this one would yield 487.18. Number 3 would give me 5,967.45. And number 4 would give me 2,965.41. Okay? If I use this formula for those intervals, for options 1, 3, and 4, I should get those answers. All right? So the greatest change, or the biggest number, was choice 2, 14,805. Problem 2. Which expression is not equivalent to 36x to the 6 minus 25y to the 4th? For some reason, these italicized words you guys like skip over. One of those is not equal, which means 3 of them will be equal. So 3 will be correct and 1 will be incorrect. So don't circle the first correct answer. How do I approach this? Well, first of all, I recognize that this is a difference of perfect squares. Okay, this actually factors out to be 6x to the power of 3 minus 5y squared. Okay, and then the same thing, 6x cubed plus 5y squared. Right? That is equal. They are equal. And if I look, that's actually choice 2. So that is equivalent. Remember, we're looking for what's not equivalent. So choice 2 is not my answer because they are equal. All right? And if I look at choice 3, it's almost the same exact thing, except the exponents are different. Okay? The exponents are different. It should be a 3 and a 2 and a 3 and a 2. See what choice 3 does? It leaves the exponents 6 and 4. That is not correct. That is not correct at all. So number 3, I know for a fact, is not correct. All right? Very briefly, in case you're wondering how I got from what they gave me to this right here, okay, I have 36x to the 6th minus 25y to the 4th. I'm literally taking the square root of these things. The square root of 36 is 6. That's why I have my 6 here. And the square root of x to the 6th, well, I just divide my exponent by 2. 6 divided by 2 gives me x to the power of 3. That's why I have these x cubes here. And the same thing goes for the next term. The square root of 25 is 5. That's why I have this written. And the square root of y to the 4th, well, I just take 4 and cut it in half. Would give me y to the power of 2. All right? And anytime it is a difference, meaning I'm subtracting those, I always write it in these 2 parentheses with 1 minus, and 1 has to be a plus between them. That's it. Now, as far as 1 and 4 goes, well, 1, what is, I'm going to erase this here. What is 6 squared? Isn't that 36? That's the same. And if I take x cubed and square it, that will give me x to the 6th. Same thing here. 5 squared is 25. Y squared to the power of 2 would give me y to the 4th. So technically, it's the same thing. And if you do the math for choice 4, it will be the same thing as well. Choice 3 is the only one that is not equivalent. Choice 3, here we go. An easy one. What are the zeros? Zeros are the same things as x-intercepts. The only thing I want to do is I'm going to graph this in y1 and see where it touches the x-axis. All right, let's go ahead and do that. The hardest part about this problem is typing this in the calculator. My God. So let's go to y equals, yeah. And I'm going to put x to the power of 4 minus 9x squared. Who cares if it's in a weird order? Plus 3x cubed minus 27x minus 10x squared plus 90. All right, I don't care. I can combine like terms. Sure. Well, just put in the calculator what they gave you and graph it. All right, so I should touch this x-axis, hopefully at 4 spots. 1, 2, 3, 4. There we go. 4 spots. I'm going to look at this graph, and I'm going to say to myself, all right, right here where x is 3, right here where x is 2, right here where x is -3, and right here where x is -5. Okay, so my answer should have all 4 of those numbers. -5, -3, 2, and 3. There you go. Choice is 4. Now, if you have difficulty counting by ones, you can always go to my table. And anything with a 0 next to it, there we go. Anything with a 0 next to it, come on, would be my answer. Meaning, here's a 0, so one of my answers is -5. Here's a 0, it's -3. Here's a 0, it's 2. Here's a 0, it's 3. So there are always multiple choices, and there are always multiple options to get to those choices. All right? Choice 4. Question 4 reads, if theta is an angle in standard position whose terminal side passes through the point -2, -3, what is the numerical value of tan of theta? I'm going to draw me a picture. I'm going to draw me an axis. And they say theta is an angle in standard position. That means it starts right here on the x-axis. And it goes to the point -2, -3. So if I go 1, 2, here's -2. Here's -3. So this point right here, this coordinate, okay, the terminal side or the ending side goes through that point. So right there. This angle that I'm drawing, that's angle theta. All right? They want to know what the tan is. First of all, I have 4 answers. 2 of them are positive and 2 of them are negative. I know that all students take, it's almost Christmas time, so we'll call it cookies. Tangent. The reason I write those letters is it tells me whatever trig function is positive in that quadrant. All 3, sine, cosine, and tangent, are positive in quadrant 1. In quadrant 2, only sine is positive. Cosine and tangent are negative. Ooh, look, tangent is positive here. That means sine and cosine are negative. And this is the quadrant I'm in. So my answer should be positive. It can't be choice 3 or 4 because they're negative. So at this point, even if I'm guessing, I got a 50-50 shot. But let's actually calculate it out. I'm going to draw a nice triangle. I'm going to draw a straight line down here to the x-axis, or up, I should say. And I'm creating a triangle here. It is a right triangle. Okay? This side has a length of 2. And this side has a length of 3. I mean, that's how I plot the point. I went 2 to the left and 3 down. So if I have a triangle, I'm going to just blow that triangle up right here. And this is 2, and this is 3. I can use the Pythagorean theorem to find out what the hypotenuse is. Because I now have the, this is the angle I'm at here. I have the opposite side. I have the adjacent side. And I don't have the hypotenuse. So I could use the Pythagorean theorem. But how come I don't even need to use it? This is such an easy question if you understand trig. Because SOHCAHTOA, some old hoe caught another hoe tricking on Alexander. All right? I need tangent. I only need the opposite and the adjacent. How wonderful that they already give us adjacent and they give us opposite, which is 3. So tangent is opposite over adjacent, which is 3 over 2. Positive. Done. Man, There's so much more in explaining these than there is in doing them. If you are comfortable with the material, these can go so much quicker. 5, the average monthly temperature, T of M, in degrees Fahrenheit over a 12-month period can be modeled by the equation T of M equals negative 23 cosine of pi over 6m plus 56, where m is in months. What is the range of temperature in degrees Fahrenheit of this function? Oh, man. Range. Domain. That's an O. Domain means all possible x values, right? Range, which is what they're asking us for, refers to the y values. So how high and how low does this graph go? Well, you can actually graph this. You can put this into y1 in your graphing calculator and use your min and max function and see how high and how low this goes. However, if you know the format of these equations, you don't even need to do that. What do I mean? This is the middle of my function. So my cosine function, okay, if I were to graph it, this would be the middle. 56 is where the middle of it is. It's a cup, cosine looks like that. So the middle right here would be at 56. The great part is 23 is our amplitude. That means from 56, I go up 23 and I go down 23. That's what amplitude means. It goes up and down. It's like an amp, right? An amp to a radio or an audio system pushes the volume up and brings it down low. Okay? So up and down. So if I want to find the max point and the minimum point, for the max point, I take my middle, 56, and add 23 to it, which would give me 79. And for my low point, I take my 56 and I subtract 23, which would give me 33. So my range, the range of my y values goes from 79 to 33. Look at that. Choice 2. Done. Now, you could have graphed it. It would have taken longer. You would have gotten the same answers. And they don't give you credit. You are not scored based on how long it takes you to do the question, just if it's right. Number 6. And I got to stop saying that these questions are easy, because I understand that if you don't get the material, they're very difficult for you. But if you put the time in and you get the material, they will all be easy. Well, most of them will be. Which expression is equivalent form of a times the 5th root of a to the 4th? First of all, if I graph this in y1, okay, and they're equivalent, that means one of these, choice 1, choice 2, choice 3, choice 4, would have the same exact graph. Meaning I would put this in y2 and see if it's the same. Okay? If it's not the same, it's not equivalent, so it wouldn't be an answer. If I put this in y2, I would check to see if it was the same as this. I can see if the graphs are the same. How come? Because I only have one variable in a. When I'm graphing something in the calculator, I can use my one variable, x. For y1, I would put x, then the 5th root of x to the 4th, and I would come up with a graph. Okay? And the same thing here. I would just use x's instead of the a. So I can do that. But I'm going to show you algebraically in case this was a short answer and you needed to know how to do it. First off, I have a times top down, bottom out. What does that mean? The top slid down and the bottom slid out. Top down, bottom out. You can change any radical. A radical is this symbol right here into an exponent that's a fraction. By that means, the top of my fraction just slides down and stays inside. And the bottom, yeah, that'd be nice if that actually worked. The bottom pops out. Okay, top, down, bottom out. Okay. Now, I know, and you should know, how to handle fractions that are exponents, or any exponents when I multiply similar bases. I have a to the 1 times a to the 4/5. I just add my exponents when I multiply. It's 1 plus 4/5. I don't know how to add fractions. Put it in the calculator. Put 1 plus 4/5 in the calculator. Okay, 1 plus 4/5. I need to have my denominators be the same when I combine them. Okay, so how do I write 1 as a fraction with a 5 on the bottom? I put a 5 on the top. Isn't 5 over 5 1? It is. Now I can add these easily. 5 over 5 plus 4 over 5 is 9/5. So a to the 9/5. That is the same exact expression. And here we go. It's choice 2. Now, I said in the calculator you could do that math. Yep, it'd be nice all the time if it worked. Turn this on. Okay. 1 plus, use your fraction function. Alpha y equals, enter. Now I'm going to add 4/5. And because I used my fraction mode, it will give me my answer in a fraction if it can be written in the fraction. And this one definitely can, 9/5. That's your new exponent. Question 7, 2 more to go. The expression 3i times ai minus 6i squared is equivalent to which one of these? You cannot use your calculator for this. How come? Anytime you have more than one variable, okay? Oh, we actually do have one variable. We could use our calculator. No, if I make that a into an x, we can use a calculator. I will show you that afterward when we check this work, all right? For right now, the I is an imaginary number. It is not a variable. I'm just going to distribute this in, okay? 3i times ai minus 6i squared. And no, I'm going to take that back. I'm not solving for anything. I could graph this, but I can't solve if there's a variable. So sorry. So 3i times ai. Well, 3 times a is 3a. I times I is I squared minus 3 times 6 is 18. I times I squared is I cubed. Remember, I add the exponents. That's an I to the 1 and an I squared. 1 plus 2 is 3. Now here, we need to remember that I squared is the same thing as -1. So I'm going to write 3a and I squared is going to be -1 minus 18. I cubed, and I hate how they make you remember what I cubed is. That's the same thing as saying -I. All right. This one right here, this comes up so much more. It's rare this one comes up. It occasionally does. But I cubed is the same thing as saying -I. So let's just clean this up. Okay. -1 times 3a is just -3a. A negative times a negative gives me a positive. 18 times I, 18i. There you go. We got negative. Okay, first of all, the 3a should be negative. Okay, a negative, and it should be plus 18i. Choice 3. Choice 3. And finally, we are to question number 8. Which equation best represents the graph below? All right, and we got some options here. I got the log of x, but then I have an a and a c in there, and I can't just graph that. But we should know the following. Okay, all of these have a log of x. Okay, that means this a and the c, that's kind of different. There's adding a's and there's subtracting a's. There's adding c's and we're subtracting c's. So they should all mean different things. And this is where it's critical that you know this stuff. Let's go back here. If let's start with the outside, add or subtract something outside parenthesis, like the C is. The A is inside the parentheses. Okay? So if I have parentheses, if I add or subtract something, we'll call that a C, outside the parentheses, that means my graph is going to move up or down. If I'm adding something outside the parentheses, I'm moving up. Okay? If I'm subtracting something outside the parentheses, I'm moving down. C. So if C was the number 3, I'd be moving up 3 or down 3. And that makes sense because my y-axis, the positives are up and the negatives are down. Now, anytime we're inside the parentheses, it kind of works the opposite. I can add or subtract some value inside the parentheses. Now, on my x-axis, to the right, it's positive, and to the left, it's negative. But parentheses, they kind of always act the opposite, meaning adding means I'm not moving to the right, I'm moving to the left, whatever this number A is. And if I'm subtracting inside the parentheses, I'm moving to the right. These are the rules that are from my notes. So you can look, let's take a look at this first one here, example 1. Okay, let's take a look at example 1. All right, example 1 tells me, okay, I'm adding, so I'm moving to the left, okay, because adding inside the parentheses, and I'm adding outside, which means I move up. So I'm literally doing this, the top one. I'm adding, so I'm moving left, and then I'm adding outside, up. So I'm moving left and up. Well, let's take a look at the second one, okay? The second one says, well, I'm subtracting on the inside and adding on the outside. So subtracting on the inside means I'd be moving right, but I'm adding on the outside, so I'd be moving up, so right and up. So what I'm going to do, now that I know what all these movements mean, I'm just going to graph log of x, what's highlighted in green at the bottom here. So I'm just going to turn this on, you silly. Turn this on and go back to y equals and graph log of x. And I'm going to graph this bad boy. It looks something like this. Okay, so I'm going to move this right here. And you can tell that my graph, even though it stops, it technically continues to go down like this. It's just so close to that y-axis, like that. Now look at the graph I have right here. It looks like if I take this blue graph right here of log of x, it looks like I moved up and to the right, doesn't it? It does. So I want to look for my multiple choice option that tells me I'm moving up. Excuse me, I said to the right. That's clearly to the left. Mr. Visca can't tell my right from my left. But I'm moving up and to the left. I took my graph, I moved up, and then I moved it to the left. Look at that. Up, because I added outside. To the left, because I added inside. It is choice 1. Got to know them rules. And we are done. I'll see you for problems 9 through 16 in the next video.
Don't forget to subscribe and ring that bell.